Well, why don't we do the very basics and just get you to introduce yourself to me? I know it's always awkward, but yeah. If you don't mind.
So I'm Blake Scholl, founder and CEO at Boom Supersonic.
Perfect. All right. Let's set the stage for tomorrow and what's gonna happen.
Yeah. So tomorrow's a big day. It's the first civil supersonic flight in about 22 years, and the first time a supersonic jet built by something other than a nation state has broken the sound barrier. And I think the most exciting part is we're breaking the sound barrier with technology that we can use to build an airliner that everyone's going to be able to fly on.
Okay, so tomorrow we have to get up pretty early for the actual test. What's the sequence of events that are going to take place?
Yeah, so tomorrow we'll all gather here at the hangar. We'll pull the airplane out, get the engines fired up, into two fighter jets that are chasing it in flight, and we'll aim to be airborne just after 8 a.m. The XB-1 will fly to the end of the supersonic corridor. There's basically the same airspace that Chuck Yeager broke the sound barrier in for the first time. That's now called the X1 supersonic corridor. We'll get down at the end of that. We'll climb up to 34,000 feet. We'll push the throttles forward, and we'll get to watch on live stream as we break the sound barrier for the first time. We've got Starlink on one of the airplanes that's flying in formation. And so we think we'll be, if we're lucky with atmospheric conditions, we'll actually be able to see the shockwave on the live stream as it happens.
That would be cool.
And then we'll come back around and land and uncork some champagne.
And this is the culmination. The company started in 2016 or 2015?
2014.
2014.
Actually, yeah.
Okay, so we're over a decade, so there's that work, and then this test campaign has been going on for
almost a year. We had our first flight. Yeah, so for me, this is approaching 11 years of effort.
Yeah.
And the airplane flew for the first time last March, and every flight we go push it to a new place in the envelope. And the way you do airplane flight testing is pretty different from how you flight test a rocket. You know, a rocket, you light the candle, and it either goes to space or it goes to pieces.
Cross your fingers.
Right,
yeah.
and
it usually goes to pieces on the first test. Yeah.
Right, and you can't do that on an airplane with a person on board.
Yeah.
And so failure is not an option for a human flight test. But the nice thing is, on an airplane, you can also test it incrementally, and so we go from test point to test point to test point. Every flight brings in something new, and we take maximum risk reduction for the next test point. So we've actually already had XB-1 at the same dynamic pressure that it's going to see tomorrow. So we flew on the last flight, on flight 11, we went 0.95 Mach at about 30,000 feet and 325 knots equivalent airspeed. And so if we take that same dynamic pressure, that same equivalent airspeed, and do it at a higher altitude, we're now 1.1 Mach. So again, every step is designed to allow us to see that the airplane's performing, it's matching predictions, such that we're controlling the risk we take at every step.
So you feel like the plane has already felt its maximum dynamic forces?
Yes, we've already, to make the rocket analogy, we've already seen max Q.
Yeah, do they call it max Q in airplane land, or?
The term is thrown around a little bit less, but we can have fun and call it max Q.
Okay. It's always that lovely moment during the webcast when you pass max Q. Let's talk about the history for 1 second. You mentioned Chuck Yeager. Fill people in. I mean, when did we first go supersonic? Was that the 50s, or was it even back
1947?
1947, okay.
So 1947, not too far from here. Chuck Yeager had the first level supersonic flight on the Bell X-1, which is a rocket plane. And then that kicked off some pretty rapid development in the military world, because we pretty quickly we got supersonic fighter jets, supersonic bombers, and then in the SR-71 supersonic spy plane, and then of course we had Concorde that flew for the first time at the end of the 1960s.
Right. So you go like military, all kinds of different supersonic crafts, then nation states come together to try to make a commercial supersonic plane for regular, almost regular folk.
Yeah, I would say not quite regular folk, but which really goes back to, I think, what was amazing about Concorde is we built a supersonic airliner in the 1960s with aluminum and drafting paper and slide rules, and converted military engines, and and it flew for 27 years, and it had one major accident, which for a 1960s design, 1 in 27 years of flying, is actually not a bad safety record. We can and should do better today, but what it missed on was actually changing how anybody really travels, and I think that goes back to the origin. So, Concorde was established in 1962 via treaty between the British and the French, and so the goal was not really, let's go build a commercial supersonic airliner. The goal was to show that Western technology was superior to Soviet technology. So it's very much like Apollo. So 1969 we flew Concorde for the first time. 1969 we landed on the moon. Half a century later, can't do either of those things. And I think this is, I think it really shows the folly of prestige-driven innovation. You can do some very technically impressive things, but it creates the illusion of progress.
And they're not lasting, yeah.
It's not lasting because it's not done in an economically viable way. And so Concorde, just to double click on it, 100 seats on the airplane, adjusted for inflation, the tickets are more than $20,000. And the seats are not even very comfortable. So even New York to London, which is, like, that's the easiest route in the world to make money for something like this, it flew half empty. And it never really changed how travel, or it never changed routine travel except for like a handful of very wealthy people.
Yeah.
And so it came and it went. And then the world, it led to this political fallout. We banned supersonic travel over land.
Well, so as I understand it, you'll know a million times better than me, but the U.S. was upset that the Europeans had done this, so we banned supersonic travel over land as just to like make sure the Concorde couldn't do it, right?
Right. I mean, I think the unofficial history, the official history is sonic booms are terrible, and we had to ban them. You can make a terrible sonic boom, but there are also many sonic booms that are totally fine. And so so officially sonic boom was bad. I don't really believe that. Instead, we had, there was an American competitor to the Concorde that got canceled.
Right.
And after it got canceled, then I was like, oh, we can't have this sonic stuff anymore.
Yeah, I mean, like unofficially, I remember being in a bar in Taipei randomly. I was doing a story on semiconductors, and I ended up in this room full of jet pilots, and I think they lived through this, and their claim was very much that this was just a political ban on sonic booms to try to help the U.S. save face.
Yeah, I think that's accurate. There should be a commonplace noise limit, because you can make a really annoying sonic boom. There was a great old episode of Mythbusters where they tested, can you break a window with a sonic boom? It turns out you can. We got to fly supersonic like 50 feet over the ground and put the boom right in the middle of the window. And if we do that with an airliner, like, the broken window is not the problem that day. Right. So there's an inverse square law. If you double the altitude, the intensity drops off by a factor of 4.
Yeah.
And having spent a bunch of time out here with XB1 and Mojave, supersonic flight's commonplace out here in the military world. So I've heard a bunch of booms, and some of them, they'll get your attention, and we probably shouldn't do that. At least certainly not at night. But there are others that they sound like somebody dropped something.
Yeah.
And you very quickly, you don't even notice them anymore. And so one of the things that I think will get figured out over time is what is a common sense noise limit. And it's not going to be nothing, but it's not going to be anything goes.
Yeah.
And then we'll ultimately be able to have supersonic flight for every passenger on every route once that's figured out. But we're trying to start really pragmatically. Like, one of the things that surprises people, I think this is also another comparison to Falcon 1 and the early Falcon 9s. We didn't invent anything. This is existing materials, existing technologies, existing production methods, with really just a focus on economics, and there's no change to regulations needed on version 1. So we can do routes that are over water at twice the speed of a Boeing or Airbus. And over land, we slow down, just still 20% faster than a Boeing or Airbus. And there's no sonic boom anywhere anybody's there to hear it. And then that will change over time.
So I've been following you guys since 2016. I think I did the first ever
You
story
did,
on Boom. So we met a long time ago. Look, I cover aerospace. I know things don't always go exactly according to plan. It's a very hard field. Everything's always on a different timeline than you first draw up. I know when you guys started, part of the mission with XB1 was, let's build a smaller version of where we hope to get to, learn a bunch of stuff along the way. It makes all the sense in the world, get the team trained up on not just building the plane, but what it's like to do that kind of mission.
Right. Yeah.
This has taken, I'm sure, longer than you guys thought. I think there might be people who make the case of, why even still be doing this now? Just move on to Overture and put all your focus there. I saw you do a tweet thread last night going through some of these points. So, I guess you're ahead of this, or you've heard that line of thought.
So we did XB1, like exactly as you said. We wanted to learn 100% of what we have to learn to know how to make a human-safe supersonic jet. And I think it really helps to remember that there's no other team on the planet that's done this. You can't just go hire a team. They're supersonic military teams, but the design is very different. Maneuverability matters, efficiency doesn't matter. And for a commercial product, safety matters, going really fast, safely, efficiently in a straight line, and being able to do that development on a private budget, not on a government budget. All of that matters. And so we could have done paper studies, but everything always looks good on paper. And then you go build things, and you find that 80% of what you learn is that you learned in the build process. And so we wanted to know that we actually learned everything. And I look back at XB1, and it's easy to look at this beautiful airplane, but I look at it, I just see lessons learned, and everything we would do differently if we had a do-over. Like the requirements we made the requirements way too hard on ourselves. We made the problem harder than it needed to be.
We were trying to go 2.2.
We were trying to go 2.2. It didn't really need to do that.
Yeah.
But we learned where the break point is.
Yeah.
We learned they're the obvious ways if you read a textbook about what's challenging in 2.2. But then there are a bunch of ways that it creates challenge that you can't learn except by doing it. Like it drives you to long, skinny airplane design, which makes the landing gear packaging dramatically harder. And so the landing gear in this airplane was one of the most challenging things. And that was, I don't think anybody really saw that coming. But now we deeply understand that. And if we had set to go out on do Overture, we made the same scale of mistakes, we would have died along the way. We would have run out of money.
Yeah.
Versus on XB1, we were just barely able to make it through. With being able to correct our mistakes before we ran out of runway. And that's enabled us to go, like the Overture that we have today is a completely different Overture that we would have conceived without XB1. It's dramatically more pragmatic. So at 1.7 Mach, it's easy to meet existing noise standards. We can use the exact same materials that were proven on the 787. It's easy to make the airplane quiet for takeoff and landing because the faster you fly, the skinnier you want the wing and the skinnier you want the engine. And that makes everything low speed harder. Stability is harder, noise is harder. But if you back off a little bit on top speed, then you can go to a wider wing, which flies much better at low speed, meaning stability is easier, landing gear packaging is easier, noise is easier, and in a transatlantic flight, it's like a 15-minute, 20-minute difference in flight times. So one of the biggest things we learned from XB1 is just pragmatism. And to really, remember, we don't have to make the first airplane do everything. We need to do enough that it changes millions of lives and puts us in a position where we can do 1.1 and 1.2 and eventually 2.0.
And it's been a journey. There's a lot of what you've done that's remarkable technologically. I think even, honestly, to still be going is like an achievement in itself, because you guys have some things against you that other companies in the aerospace sector that I cover do not, which is if you're a rocket company, you're good at what you're doing. You're in line for NASA contracts. You're flying military satellites. You're getting government contracts, even in the defense sector on very expensive things. Obviously, the same rules apply. This is hard because you guys are doing a nation state type thing. And yes, this might have some knock-on effects for things that the DoD or the US government desires, but you're mostly like on your own, having to see through ups and downs in the global economy, investment, things like COVID in the middle of all this.
Yeah.
So, the deck has been like stacked against you guys in some ways compared to people that are just barely adjacent to where you are.
Well, we definitely didn't choose the easy path or the easy mission, but I looked at this, we've always said, is there an easier way to get this done? And I've certainly never found it. I deeply believe that supersonic passenger flight needs to exist. If you go down a defense path first, you end up building something very different. You end up building a weapon system, and that should exist. But it's probably hypersonic, and it's not. It'd be a very long time before that stuff is passenger ready.
Sure.
And yet there are defense applications of the commercial supersonic technology, like being able to move the president around. Like the American president, by the way, the French and the British prime ministers have arrived on supersonic jet before. An American president never has. We should fix that. And there are other, and it's not just prestige, there are use cases that matter. Like we're rallying our allies, for example, to support Ukraine. How many capitals can the Secretary of State visit in a day? How quickly can we get a special operations team anywhere on the planet to respond to a crisis? Like there are a small number of use cases that really matter. Can we get a wounded soldier to life-saving medical care? Like that stuff matters, but I would say it's a moderate volume, high value use case.
Right.
It's not something you build the whole program around. The program is built around the commercial use case, you and me being able to travel.
Yeah.
It's built around United, American, Japan Airlines, who are our initial commercial customers.
You said, I think you're happy to talk about some of this. I mean, I'll ask, it's been a journey. Raising money to keep this going is hard. I mean, how close has it come to near-death experience?
I think we have, it seems like we have a near-death experience about once a year. And there are times where, things would happen and it's like, well, this might be the one that gets us. And the key thing has always been never to give up. And we had deals fall apart. We had I think financially, we got down to 7 days of cash at one point.
Yeah.
And
this isn't a SaaS product. It's like you guys. This is a thing that costs hundreds of millions, billions of dollars to pull off.
Maybe we should start calling it Supersonic as a service.
That would, you just got to frame it.
That's right. That'll work, right?
Yeah, but I mean, it must have just been crazy. I mean, it's like so tantalizing. You can see this, and you're making progress, but it could all get.
I think the most important thing is to pick a mission that is so inspiring to the team working on it that they never seriously think of giving up. And I think back to my first company, we built a barcode scanning game. And it's like the least significant thing one could possibly do on the planet. And I would get up but it's a startup, and it was hard in all kinds of ways that startups are always hard. And I would get up in the morning and think, why did I get into this? And so when there was an opportunity to acqui-hire the thing into Groupon, and investors made a bit of money, and I got to get some savings, that was like my escape fantasy. And I wanted to work on something where I would never think I wish I hadn't tried. And there have been and continue to be days at Boom where I look at it and I'm like, I don't know how we're going to get through that. But there aren't days where I think I wish I hadn't tried.
And to get to Overture will require more money.
It will require more money, but it's actually, if we do it efficiently, and I think one of the biggest things out of XB1 is lessons learned on how to do it efficiently. If we do it efficiently, we can get done for an obtainable amount of money. And that's, if we look on XB1, for example, we had just about every combination of supply chain strategy you could have somewhere on the airplane. We have parts we designed and built ourselves. We have parts we designed where we had suppliers build it to our specs with our own people embedded. We have things where we've got off-the-shelf parts. We've got things where we had an off-the-shelf option, but we had a supplier build us something custom instead.
Yeah.
Like every combination you could imagine is on that airplane somewhere. And one of the nice things is we get to look back at it now and say, what enabled us to go quickly? What enables us to go efficiently? And what didn't? And with and so what makes us slow or inefficient has been when we're worried about hurting somebody or breaking a part that is either expensive or time consuming to replace, or making a decision that's difficult to reverse. So safety, cost of a change or cost of a mistake. And if we can engineer a development program such that those things are minimized, we can go really fast and really efficiently. And part of doing that is having a lot of vertical integration. All the vertically integrated parts work best. And so that's going to play forward onto Overture, and it's part of why we're doing our own engines.
So you've got the engine program, you guys have a factory in North Carolina. Like, where are we at with Overture and where that program
So
picks up?
Overture is about, in about 2 weeks, we're going to, quote unquote, break the engineer's pencils.
Okay.
Meaning, stop optimizing. The design's good. It's time to take it to detailed development and production. So, the final Overture that we have, like I said, like literally 2 weeks away from it. Most people won't be able to tell a difference from what's on our website, but there's a lot of learning and optimization that's gone into it. And then we'll be building the first one in roughly 18 months. Our goal is to roll off the line in North Carolina in about 3 years and have it in the air in 4.
And again, there's going to be people who, you guys have an engine program, right? I mean, notoriously difficult things to build. Staying on time with those things is near impossible traditionally.
So one of the things I've come to believe, and this is sacrilege, but I'll just say it, like the most important thing is efficiency and speed of development, not predictability of the end date.
Yeah.
Like I predicted this thing was going to fly a long time ago, and I was wrong.
What was your earliest guess?
Like when we started, I thought it would take 18 months.
Yeah.
And
I remember the first SpaceX press release was about 18 months when they announced the company.
The schedule inflation on XB1 is very similar to Falcon Heavy.
Yeah.
I think it went from like 18 months to 7 years. And that was about, depending on where you start counting, that was about
us. Falcon 1, it was 18 months went to almost 8 years. Yeah. Yeah.
I thought Falcon was a bit faster than 8 years. No.
2001 to 2008. So, okay, we'll give it 7.
7,
yeah.
Okay. Yeah, so it's, if you try to focus on it, and this is one of the tricky things is externally people look at it and they judge you on timelines. So now you want to set a timeline that you can meet 100%. Okay, if you can meet it 100%, you're going to pad it because you're going to need to pad it for the unexpected. But if you pad the schedule with the unexpected, nothing ever gets done ahead of schedule. All of the work expands to take the time it's got.
Yeah.
So you miss the padded schedule. And every time we try that internally, we like, oh man, we need to have a schedule that people believe. So now we pad it, and now we miss the believable schedule. And I've come to believe that's just the wrong way to do it. What you do is you set an aggressive schedule, like assume that everything is going to take about 15% less time than it would be reasonable for it to take, and assume there are no unexpected setbacks. And then when you get to a challenge, so that has everyone leaning in, and there's a little bit of pressure. A little bit of challenge, and when you find a mistake, you find the most or a setback or a challenge, you find the most efficient way to overcome it. And so that's half the answer. The other half the answer is not blowing past design gates. What the heck do I mean by that? So when you design an airplane, basically it starts with a very abstract like napkin sketch, and then detail gets filled in. So you can imagine like a painting where you start with an outline, right, and then you paint in a little bit of the background, and then there are like three passes. I mean, if I'm actually an artist, I could describe it better. But like detail comes in over time. And airplane design is the same way. And as you go from the pencil to the first paintbrush, you want to make sure that the outline is correct. Because once you start painting, it's a lot more difficult to change it. And so we want to lean in aggressively in the schedule, but when we're ready to go from pencil to paintbrush, want to make sure we really have the pencil drawing right.
Yeah.
So those two elements together, rigorous design gates and aggressive schedules, I come to believe are elements of what is actually the fastest path. Now, does it lead to predictability? Not really, but at least the earliest actual possible date.
It's cool because I've known you since you were a web, coming from the internet land, and to see how you've had to live through this and learn these lessons and like this framework that you've built.
The learning is really important, not just for me but for the whole team. Like a thing I've told the team from day one, the most important thing in XB1 is not the airplane in the hangar, it's the knowledge and the minds of the men and women who built it. And we've got that now. That's the most important thing, is to learn. Right. And for me, I sort of envision it as, so I'm a pilot, so I think of everything through airplane metaphors. But I'm like flying my airplane towards a mountain range, and the mountain peaks are definitely higher than my altitude, so I have to climb.
Yeah.
But can I climb fast enough that I don't hit the mountain? And so like the rate of learning for me personally and for the team as a whole is really important.
All right, we discussed some of the challenges and struggles. One of my favorite things to talk to you about is actually the idealistic future version of this. We were having dinner a couple months ago, and you were telling me about how you see Overture, maybe not just at big airports, but maybe, the U.S. has this great thing where we have these smaller airports all over the place where you fly private today. And tell me, like, I was getting into this, your vision of the experience of, if everything goes well, what this could be like.
Yeah, so if I think beyond Overture 1 and think about the product family that will exist, like the future that we want is when supersonic travel is actually not special anymore. It's normal, and it just disappears into the background. We all just live on Earth. And the same way that today, we don't really think much about going to the other side of town, imagine a future in which we don't think too hard about going to the other side of the planet. And so you're able to go to, maybe there'll be air taxis, and you get to an airport easily. And then airports today are kind of, everything is like slow gearing. You got to get there a long time before the flight, and then it's a shopping mall, and then getting through the whole system is painful and has a lot of delay. But if everything's geared around speed and efficiency, imagine you can get to the curb 20 minutes before your flight and still make it. Imagine you get to you don't go to an airport lounge. The only reason the airport lounges exist is because the uncertainty of getting through the airport is so high that you got to get there a couple hours or an hour or whatever before your flight, so you don't make it, so you don't risk missing it, rather. But if you can change all that, you just give an enormous amount of time back and an enormous amount of hassle back, and that will require ultimately changing the system around us, not just the airplane. But even for version 1, we just really think about how do we make Overture an oasis in the sky.
Well, and the things you are outlining. Again, this is everything's going well, and you guys get to do exactly what you want to do, but you're talking about building out like a kind of custom airport just for you guys kind of flights and the experience you want to have. So,
yeah, to be clear, none of that's in like the minimum viable product.
No, I know.
It's all in the maximum possible dream. Yeah, today there are decent small airports. I don't believe there are actually any good large airports. Yeah. No one's figured out how to scale an airport to make it efficient and pleasant, but it's not impossible. It's doable.
So, yeah.
And when we speed up flights, it actually puts pressure on the rest of the air travel system to bring the speed up and to bring the experience level up. So to double click on that a little bit, like long before I started Boom, every time I got on a flight, I would ask myself, what would this thing be like if somebody with the level of care of a Johnny Ive had designed it? And the moment you put that lens on, like you start to see all the seams and gaps and like ugly colors and visual noise and auditory noise and just all the little details of the experience that contribute to being stressful and unpleasant.
Yeah.
And we are, as just one example, if you just count the layers of seams and gaps between the outside of a window and the inside of an airplane, it's obnoxious. And we've got a mock-up of the Overture windows in our headquarters because we want to make the calmest possible window treatment. And probably very few will actually consciously notice it, but it'll result in an experience that's so much more tranquil.
Yeah.
And so that moment of stepping on board will be different, which will then knock on to, why does an airport feel so bad when the airplane feels so good?
Yeah.
So then it's going to rise everything else up.
All tides. What's going on behind us? Do you know?
So we are final pre-flight inspections. It looks like we've got power on, and
What can they access through these?
Yeah,
it's
so
like the avionics and.
that is the avionics. Yeah, so the systems bay is right that part of the airplane, and there's a digital side and there's an analog side, and this is the digital side. So the data acquisition boxes, you can kind of think of XB1 as like a flying data collector. There are literally 10,000 wire terminations on the airplane. There are 6 data acquisition boxes that lead to roughly 10 megabits of data off the airplane in real time back to the control room. And so that's we're just checking everything out before tomorrow's flight.
So each one of those you're probably getting to a different electronics subsystem.
Yeah.
And so one side's digital, one side's analog.
Yeah. So this side is digital side. If we went over to the other side, we see the mechanical equipment.
Okay.
We'd see the flight control cables. We'd see the cabin pressurization systems, the air ducts, and one of the interesting sort of technical details on XB1 is we wanted to keep it as simple as possible, but also learn everything we need to learn. So that the flight controls are this fascinating analog digital hybrid. So they are kind of old school cables, push rods. So literally there's a mechanical connection between the pilot's stick and the hydraulic actuator that drives the flight control surfaces. However, there's a digital piece in the middle.
Right, because it's fly-by-wire, right?
It's not fly-by.
Okay.
So it's mechanical, non-fly-by-wire,
yeah.
but with digital augmentation.
Okay.
So there is a digital actuator that sits in series with the rest of the flight control system. So it takes the pilot's input and then it adds a digital input on top of it.
Okay.
And we designed that in such a way that we expected the airplane to be able to fly with all the digital stuff turned off. So it's not safety critical,
yeah.
but it allows us to cut our teeth with how you do digital flight controls, because Overture will be fully digital fly-by-wire.
Yeah.
And we didn't want to tackle that on an airliner for the first time.
Yeah, okay.
On the other hand, if you go completely digital, now it's safety critical, and it makes the development dramatically more challenging.
Okay. Can we tell the orange chair story?
We should absolutely tell the orange chair story.
So all these years ago, I wrote this first story about you. We had a photographer come by who, it wasn't me, but was somebody, who got hired for this magazine piece. And I remember you were okay with the story I wrote, but not, didn't love the photo.
So.
And this is kind of like your coming out party and everything.
Yeah. So I many reflections on that time. I don't think we realized how early we looked. And
so it was we had a cardboard
mock-up of XB1,
right? Yeah.
And we had this like plastic orange chair, and I will say your editor's photographer took a picture of me climbing in that thing.
Yeah.
And then I think the editor also wrote the headline, and I remembered it as something like, "This Colorado company thinks it can build a supersonic jet."
Right.
And then it's got that terrible picture of me. And so the way that week went, so you had written a really wonderful kind of coming out of stealth mode story, and my thought process is, okay, that will come out on Monday. We are going through Y Combinator. Demo day is Wednesday. Like, this will be the perfect launch of the company. And so your story comes out. Your editor picks the picture, which I should never have let him take it.
Yeah.
And then we're at the top of Hacker News, and it's like a laughing stock. It's like, don't they know that airplanes aren't made out of cardboard? And
I remember you called me. You were not happy.
I was a little upset. The comments were things. You should never read the comments on the internet, but it was like, what idiot runs marketing? Why would you name an airplane company after the sound of an explosion? So that was Monday. And then Tuesday, we got a deal done with Virgin.
Yeah.
That we've been working on, but we didn't think was going to come through for basically a pre-order and 10 airplanes. And
because I described the plane so well, man.
Right, you enabled it to happen in 24 hours. So I remember on Tuesday, I was going over my demo day slides, and we get the email from Branson, and I had to read it 3 times before I believed it.
Yeah.
And I was like, I think we get to relaunch the company. And so I stayed up late that night doing all the press interviews, and we relaunched the company on demo day. And it's like, okay, now this laughable supersonic jet company has an agreement with Virgin. as they actually want the airplanes.
Yeah.
And then now, bam, we're at the top of Hacker News again. And this time the comments are like, "Wow, that's how you launch a company. It's the 1-2 punch. Like, what genius runs marketing there?"
Yeah.
I'm just reading this thing and thinking, boy, we just lucked our way through that.
Well, you join a small but powerful club of people who, because I remember you're like, I'm not gonna ever talk to you again. I've had this chat with Elon as well,
Yeah.
and I end up talking to Elon again, and we've patched
I'm very glad we did. And
So
you know,
when I heard-
in retrospect, I just needed to manage the photographers. The lesson I told the team is don't let somebody take a picture
Yeah.
that you're not happy being the headline picture.
Yeah. I was like, oh, I'm sorry, man. I don't know what the photographer's doing. But I heard the orange chair became part of like Boom.
Oh, yeah.
It's on the Slack channel or something.
Yeah, we have a little like orange chair emoji,
Yeah.
and somewhere in the office we still have the orange chair. And
What does the emoji symbolize when it gets used?
oh, it's a little ineffable. It's like early funny, haha.
Yeah.
Yeah, it's like an inside joke amongst the people who've been here the longest.
Yeah. Well,
The vast majority of the company wasn't there for that.
I feel like I contributed to Boom mythology.
Absolutely.
Okay, well, this has been fantastic. Assuming everything goes exactly as you hope tomorrow, you mentioned the champagne, and then otherwise what? Just like a feeling of relief,
Yeah.
excitement?
Well, I mean, in some ways, like mentally, I'm already focused on the next stuff. And the nice thing is after a couple flights here, like the rest of the team will be too. So we're going to fly Supersonic, tomorrow, and then we'll do a second Supersonic flight about a week later. Just want to prove to everybody it wasn't a fluke.
And then this goes in your garage.
That's right. And then most important is the team will take a deep breath, and then we're going to combine Overture and XB1 teams, which will be a big deal because it'll double the size of the engineering team that's working on the airliner, and then it's go time.
Yeah, and you will put this in like the foyer of your house, right?
We have to work. Right now, the lobby is not big enough, but I do want to find a way that when you walk into Boom, the XB1 is the first thing you see.
Yeah.
Because I want everybody coming to work to remember this is a company that builds badass hardware and that we can do things that people said are impossible.
SpaceX has a dragon hanging up in Hawthorne that you walk, held up by some wires, and
The inspiration's really important.
Yeah.
And like there are, because every single person working on this is going to face problems they don't know how to solve. And the mission being inspiring, remembering that we've done things that people said we couldn't do, I think is how we get through those moments where we don't know how we're going to get through them.
yeah. Well, I wish you nothing but the best of luck tomorrow. I'm excited to see it, and thanks for letting me come back again.
Of course. Thank you, Ashlee.
That's awesome. That's great. Thank you.